This is the sprint through video for F5 Quantum. Here's a quick overview of our project. Our project aims to address the problem that the security of cloud applications is threatened by the future of quantum computing. In order to have cloud applications, there's a giant tech stack that's needed. Within this tech stack, a lot of the different parts offer security, but none of them use quantum resistant algorithms. So our project aims to bring quantum resistant algorithms to those different parts of the tech stack. Our first objective was to create quantum resistant prototypes of just one specific type of the tech stack. So we started with proxies and we focused on Nginx and Envoy. We created quantum resistant versions of these proxies by including building them with quantum resistant algorithms. We created a Docker file that has the instructions for how to build these quantum resistant proxies. And so someone can just run them from whatever computer and automatically have quantum resistant Nginx and Envoy. In addition, we also created scripts to run demos of these proxies working to deploy applications. These demos prove that the quantum resistant proxies have the same functionality as the original proxies and that they are secure. Our third objective was our most important objective, as the scope of this project is huge and our contribution is just the beginning. Although we have created working quantum resistant prototypes of part of the cloud service mesh, there's an incredible amount of work to be done by experts in the field, as quantum computers will change the way that cloud security works forever. This project will be open source for others to continue working on in the future. Because of that, we have focused on educating others on our project through presentations, as well as by creating a blueprint plan for future development of other parts of the tech stack. Here's our demos. We'll start with the presentation that we gave at a Cloud Native conference in Detroit.
In July of 2022, the National Institute of Standards and Technology announced the 4 winning algorithms from their 6-year effort to call for the world's cryptographers to find the best algorithms that could resist a quantum attack against the quantum computers that are expected to exist in the future. The winners for digital signatures were Dilithium, Falcon, and Sphinx. Extensive research has been done on these algorithms, and we chose to use Dilithium for our prototyping, as it is the fastest of the post-quantum encryption options based on the literature performance thus far. In July,
here's a quick demo to show you that we have Nginx working with a quantum resistant algorithm. Again, Nginx can be used as a front end or for routing servers within the cloud service application. So we're going to start by running a script that we created, and this script makes sure that Nginx is built using the quantum resistant algorithm. And if we scroll all the way up, we can see that Nginx is using this quantum resistant algorithm called Dilithium 3. Then in another terminal, we can run a script that we created that checks and makes sure that Nginx is working properly. And as you can see, it says welcome to Nginx. So this means that Nginx is up and running. Okay, in terms of activities in progress, we completed more Envoy benchmarking. We also finalized our presentation slides and then ended up giving the presentation, as I mentioned, in Detroit. And so that took a lot of preparation and practice beforehand. And we also got to network at that conference to share our project with other people. And then after the conference, I met with my sponsor. And so he decided that he wants me to create a blueprint to show which parts of the cloud native stack should be upgraded to use post-quantum cryptography to help other people who work for various companies within the tech stack easily be able to integrate quantum resistant algorithms into their part of the tech stack. So I created a plan to deliver that, and then I also compiled notes on which parts of the cloud native stack should be upgraded to use post-quantum cryptography. So a few things changed. One thing was that we added more benchmarking for Envoy. Specifically, we did benchmarking for the regular Envoy so that we could compare it to Envoy with quantum resistant algorithms and see if they run at about the same speed. We also created some demo video explanations of our previous demos. And then, as I mentioned before, we started with the cloud native blueprint work. There was lots of value in what we did in terms of our project objectives for benchmarking. It proved that the post-quantum service mesh is reliable, and then also for the presentation and cloud native blueprint that helped lay the foundation for future work on our open source project. In terms of knowledge and skills, one aspect of knowledge that we needed was how the cloud native stack works for small applications to build this blueprint. And then an important skill that we needed was the ability to present to an audience of different backgrounds, as not everyone at the conference was familiar with quantum computing. In terms of challenges, one of our main challenges was that our sponsor didn't really tell us what we were going to be working on after the conference. And so I had a meeting with him to ensure that I was on the proper path for our next steps. And for our retro, one thing that I learned that was important was to practice in the presentation and the location you plan on presenting, unless that's not possible, because we did not do that. And then we ended up having a hiccup when we were screen sharing because the way that the screen sharing worked in that room was different than where we presented. In terms of future improvements, we want to reach out to other people in the cloud native community for help. In addition to our sponsor, because we met people at the conference, so we might as well utilize them. And then I also want to create more issues on GitHub.